All right, well, everybody is taking the survey. We're going to get started. So I'm Pamela Trussell, the founder of New Past Plastic, and you are here today to take a look at the draft recommendation, a community-driven framework for assessing health and environmental risks of the Conodoguinet Creek watershed. These are some of, I call them my big sisters that I work with regularly. But this project is meant to be working with local and community organizations and businesses and individuals to be successful. We're going to be going over why we are doing this project, what we're doing in the project, and how, to the what we'll cover slide. Okay, and then we'll be, after we discuss the how, we're going to discuss strategies and solutions, and that's where, you know, you're critical to this project. Next. So we're going to learn why we should protect. If you see the pile of logs on the island there in the middle of the Conodoguinet Creek, they're piling up. So pollutants are also piling up in our watershed and ending up in the Conodoguinet Creek, but they're all over our watershed. Next. I'm going to be going through things just a little faster. Keep clicking through these. These are just some of the reasons why we should all engage in protecting our watershed, because these are things that we all hold dear to our hearts. So I first came across this primary tributary that leads directly into the Conodoguinet Creek up in North Middleton from a legacy landfill. And that's when I realized that that beautiful creek with those pictures of me paddling in and other people enjoying could possibly have pollutants in it that impact us. Next. So why that's buffering? Buffering over. If you guys could do this Mentimeter, and it's going to ask you some questions, and we're going to just kind of understand a little bit more about you and what you're currently, you know, doing and your understanding is. Astrid will put the Mentimeter in the chat, as well as you can scan the QR code. Now, originally, I wanted to show the Mentimeter. I'm a little leery of dropping the PowerPoint, getting out of it and going to it. So I think on my end, since I'm no longer doing the PowerPoint, I will look at the Mentimeter and let you guys know some of your answers. And I don't know. I guess we could risk it. The whole point was for you guys to see. I'm like, oh gosh. You might could see it on your phone in real time. So what I want you to do is just questions 1 through 3 for right now. So the first question is, name the pollutants you're most concerned with. So these are pollutants that you're currently maybe working on to mitigate. There are some maybe that you're not working on, but you're still like concerned about them. So you can put up to 5 things in there. The next question is, name some emergent contaminants. You can also put 5 options in there. When we're done with the PowerPoint slides at the end for Q&A, this does look really cool, guys. So we'll go back over our Mentimeter and let you guys look at it. So what I'm seeing on the screen is a lot of PFAS, microplastics, PCBs, bacteria, chemical waste. And for the, should be migrating to our last one here. Who is protecting us from these pollutants? And you can put up to 5 responses on this as well. You don't have to fill in all 5 on it or on any of these. It's just allowing you up to that, I think. Okay, so far what's populating for this last question are watershed organizations, EPA, local citizens, government agencies, willing landowners, Cumberland County Conservation District, DEP. Awesome. All right. Okay, so basically, the Stockholm Convention has determined that we've passed the planetary boundaries of safety. That means the Earth's ability to absorb, break down, or dilute things so that our natural systems can function at their normal and well capacity, I guess. Next. So, but what we're seeing is that the production of chemicals, we have 350,000 chemicals currently produced. One chemical is manufactured every 1.4 seconds. If you look at this graph, all I want you to take away is that the production is going up significantly and that the production is for the petrochemical industry, otherwise known as predominantly plastics. Next. And so the fossil fuel industry throughout is contributing to a lot of these chemical toxicities and of course microplastics through all these various modes. Next. Like I said, guys, I'm going to be making these slides super short because of the delay. And there's about 16,000 chemicals in plastics and 4,200 are highly hazardous, but very few of them are have been put on the TSCA hazardous list. PFOS is one of the ones that has just recently been put on there, even though the industry knew they were toxic through their own studies back in 1960s and 70s. Next. So these are some of the chemical classes. So like PFAS, there's about 15,000 chemicals in the class of PFAS. There's a bunch of other classes of chemicals where there's a lot. And what happens is we get what's called regrettable substitutes. So for example, we had long chain PFAS, then they started making short and ultra short chain PFAS, and now they're more soluble in water and migrate more and circulate through our air. We had BPA, and now we have things like BPZ and BPS and things. So they're finding that these substitutions are just as toxic as the original chemicals. Next. And then on that slide, you could see that pesticides are there and basically PFAS are in those pesticides. This is actually a slide that I pulled for the chemical toxicities in synthetic playing surfaces, otherwise known as artificial turf poured in place. These are some of the chemicals of concern that we'll be talking about. and they come in many of our other products along with the artificial playing surfaces. Next. Here's some of the recent news studies. One through Penn State, is very concerned with high levels of PFAS chemicals in our waterways. Another is showing the alarming presence of chemicals in cities. That study is where some students wore wristbands and then they collected the chemicals. And just from air exposure alone, they had high levels of endocrine disrupting chemicals and pesticides, very high in that. And you can also see that there's widespread occurrence of glyphosate and its precursor that it changes into later, and pesticides really elevate levels of prostate cancer. Next. So these chemicals are literally, and microplastics are traveling through our water cycle. And plastic is not only contains a lot of different chemical components, but other chemicals will adhere to plastic. So they become vectors for transporting chemical contaminations and bacteria and viruses and other things as well. And the smaller they get, the larger their surface area, so the more contaminants they can transport. Next. Okay, so the disease rate over the US in 30 years, you can see all these subset of diseases are just increasing pretty much exponentially. I had another slide that was showing how vector-borne diseases used to be the biggest factor for death, and now it's non-communicable diseases are, basically your cancers and things like that. Next. So the chemical toxicities and microplastics, they're in our soils, they're in our water, they bioaccumulate. Most all of these chemicals are bioaccumulating, meaning they don't break down in the environment. And so they accumulate up the food chain and in us. And in fact, these chemicals are impacting the most vulnerable population, and that is the fetuses and the young children, our youth. In fact, they tested and found 43 of these hazardous chemicals in the pregnant women. And these are some of the groups of chemicals that are found in them. And they come from our everyday products, from food packaging to our drinking water, and anything you eat off of that's plastic, your cosmetics, your shampoo, etc. Okay, next. So some of the things that we can look at are non-point sources. And if you want to skip to that slide, Kira, keep going. So some of these include, textiles, development, biosolids, agriculture, tire crumb, litter that breaks down into microplastics. 30% of the air you breathe, the dust is microplastics. Next. So the microplastics and their chemicals are impacting the soil substructure, the actual composition, if you will, as well as being uptaked into the plants, and then, of course, consumed by the livestock, gets in the milk, gets in the meat, the eggs, and gets into us. So it's a big deal. So going back to your Mentimeter, we're going to do questions 4 and 5 here. Okay, so can you name some examples of point or non-point sources in the Conodoguinet Creek watershed that you have that might be contributing these pollutants that we've been talking about? Or if you know they are. So do you know of any locations that are or could be? Okay, some things that are coming in are parking lots, airports, food processing residuals, wastewater discharges, sediment, nutrients, airport.
We have to mention the pipe.
Yeah, we will. So what the next one is, if there is any, do you guys have any specific pollution incidents or locations that you're aware of? And so Karen was mentioning a pipe at out in Middle Spring that is groundwater coming from a what they think was a former legacy furniture manufacturer, and is putting large amounts of PFAS into the Conodoguinet Creek, and they're finding it all the way downstream. We'll talk about more specifics that we're aware of as we go on. Okay, Kiara, next. So most of you are aware that Cumberland County is the largest, quickest growing county in the region. And so we are surrounded by a lot of farmland, but it is being overtaken by development. Next. And both of these, agriculture and development, are going to contribute to pollutants, some of the same exact pollutants, but in different ways. And some of the point sources that you guys did mention were the airports and wastewater treatment plants. But as you'll see, some of our industry is contributing. These synthetic playing surfaces contribute up to 15 what's the term? Sorry, my mind's doing a blank. 15% of the meso something or other. I'm like, all of a sudden it just like left me. But basically, microplastic particles into the watershed is coming from those artificial playing surfaces. They can shed up to 3,200 pounds of microplastic per playing surface. Military bases, anything to do with the petrochemical, will be going over some of the petrochemical contaminant leaks that we've experienced here in a minute. Go ahead. So this is a picture of just facilities that could be exposing us to PFAS. Just so you kind of understand the map, what's circled is Carlisle. Okay, so that's a lot of wastewaters in there, Army Barracks is in there, Carlisle Syntex in there, as well as some technological manufacturers. They work a lot with PFAS, but there's also going to be other chemical groups such as polyaromatic hydrocarbons and several others that Kiara and Marissa will be going over. Next. This is some violations from the Carlisle barracks. Some tanks have leaked. There's one that happened in April in Mechanicsburg, I believe, and then another time in October that right on the creek that leaked into the creek of 2023 as well. Next. These are some of the violations from just the brownfields here in Carlisle. Next. Crystalline is the largest PVC manufacturer, one of the largest in the entire country. And click next. And so we're trying to encourage municipalities not to replace their lead pipes with PVC, to not use it. You can see the prioritization chemicals for Tosca is PVC at the bottom, or vinyl chloride. Okay, so that's on their list. Next. Next, kind of covered that. Those are like little particles that when they installed at Latort Creek, their port in place was off in the grass and can get into Latort Creek and impact it. This is what it could look like in a few years, and there's already wear at the Latort Creek port in place, and the YMCA also has artificial turf and just installed port in place that the kids are playing on. It's so toxic that they tell you if you play on these surfaces, you need to take off your shoes before you get in your car, put a towel down, and when you get home, leave your shoes outside, turn your clothes, and go, and you and your clothes go directly into the wash. But yet we're saying, hey, most vulnerable kids play on these surfaces. Next. These synthetic playing surfaces are ending up in our Pennsylvania agricultural fields. So imagine all the microplastics and toxicities that are now on that farm field. They're just being dumped because the landfills don't want them. They cost too much money to put in a landfill, and they're not recyclable. Next. Okay, so one of the biggest things that I realized at first when I started this project, I did it because I knew there were a lot of chemical toxins in our environment coming from everywhere. And I was focused on, hey, let's find them, let's test for them. That's still #1 priority. But what I've realized is we cannot just look at our chemical sources and locations, that this is a true environmental injustice. Few chemicals have been labeled as hazardous and are regulated, #1. So even though we're going to be paying attention to the ones that have been designated as hazardous, there's so many more. And it takes years to put a chemical on the hazard list. And then once it's there, like PFAS, it's still going to take years to to enforce the regulation. So like Pennsylvania now has a maximum contaminant level for PFAS in our drinking water at 14 and 18 for 2 of them, and then another 4. But the EPA has set basically non-detect levels for another subset of chemicals. But it's going to take until 2029 to mandate that our public drinking water systems comply with those limits. And that entire time, plus in the past, right, were drinking that as well as these other chemicals. So I just put in a filter, reverse osmosis, with minerals, right? But what about the large subset of population? They can't afford to put in a filter. And so that's a social injustice. There's a whole bunch more, but we're short on time. So moving on. Industries self-report. Like I said, DuPont knew it was PFAS was toxic, but it didn't get found out and put it, notified to EPA until 2000. They also self-report pollutants. So they're just on the news. I saw that it was a spill happened, and it was 6 weeks before the public was made aware of a spill. It's also very, very difficult to obtain pollution reports and public data. Regulatory agencies are understaffed, they're underfunded, and they aren't in the community. So they're doing their absolute best. I've been talking to people from DEP, from USGS, from EPA, and they are the most incredible people you could come across. So helpful. But, WEX, which is what is the portal where data goes in to be put on how is my waterway, he said they only have like 7 employees for the whole country for EPA, So also industry influences our governing leaders, and they're dismantling the minimal regulations we have. And the greatest health, mental, and physiological impacts are impacting communities of Brown, Black, Indigenous, and low income, and our most vulnerable population, our youth. Also, our ecosystems and their inhabitants, they don't have a voice. We're their voice. So when we brainstorm and we work on things that we can do to address pollutants, we've got to not just think about the pollutant in the source. We have got to think about the people and the proximity and their burdens. Next. So there's intrinsic and extrinsic factors. I'm going to let Marissa and Kiara go over this next. And then community and individual level vulnerabilities, psychosocial, social determinants, and comorbidities as well, to all take into consideration. Next. And the proximity to, say, like drinking water for the chemical sources is of importance in population, geology, lots of factors to take into consideration. And all of this has huge economic impacts as well, because we know to get changes done, you've got to show that there's a monetary connection. It's not just enough to say, hey, it's creating bad health. So this doesn't even include a lot of key aspects in that slide either. And then next slide. So this is just for the estimate lifetime exposure for just plastics alone in the US. And that's all. And I would now like to introduce some people from our team. And let me just.
That's not Texas A&M, by the way.
Oh, hold on just a second.
Somewhere in Texas.
It's huge all around.
All right, so Shashank Anand, he is a postdoctorate researcher, research scholar in the Department of Biological Agricultural Engineering at Texas A&M University. His primary focus involves enhancing the model approach for organic carbon dynamics under various land management practices and shifting climate conditions. and he has his PhD from Princeton in 2023. All of the people that are on here, my team, are the most amazing individuals. They are doing this completely voluntarily, and I have trekked them through a field of constant discovery and pivots, and they are just walking this journey with me, and we're all doing the best that we can, and appreciate your time. Go ahead, Shashank, take it away.
Thanks, Tamila. And I heard somebody saying that in the background, that's not Texas A&M. I wish it was.
It was me.
Um, yeah, I miss mountains, by the way. Okay. So I just wanted to introduce how we got into this project and how we started working on this. So for those of you who don't know, American Geophysical, called AGU, is a global community that supports almost, I think, 500,000 scientists, researchers, and professionals who are working in earth science and space sciences. Next slide, please, Kiara. Thank you. And they have this initiative called Thriving Earth Exchange, which tries to bring community and scientists together to collaborate on a project that has importance for a certain community. It can be a non-profit organization, it can be an individual, it can be anybody who is concerned with any of the environmental issues in their backyard. Um, and the way it works is that a community lead, in this case, Camilla, who knows a lot more about microplastic and chemical pollution than me, um, she applied for a project to understand the state of chemical pollution in Conodoguinet Creek watershed. And so she represents the voice of the people who are there, who are concerned with this kind of pollution, or whether or not we know about how much it is there. And then there are some scientists who wanted to work with community members. So those are called community science fellows. So I'm one of those fellows that AGU selects. And and our job is to somehow facilitate and develop that project with community lead. And then once we know what we want to do, we started looking for people who can help us, or scientists who can help us with their expertise in addressing those solutions. So you can think of me like a project manager for this particular question. Um, Next slide, please. So yeah, that's the team. It's community lead Tamila. Um, I'm a community science fellow, Shashank, and then we got three amazing community scientists who are very passionate about environment. So we have Astrid, and three of them are going to talk about the whole project. So I don't want to take too much of the time here. So Astrid is a science educator from Texas, and she has been leading the outreach and science communication aspect of this project, and you'll see the amazing work she has been doing. Then we have Kiara from Princeton University. She works on biodegradation of PFOS in soil and river systems. So she knows a lot about the chemistry and the chemical part of the project, really. And she's an expert in that. And then we have Marissa, who is a geospatial analyst at one of the renewable company in California. And you will see the amount of information she has been able to put together for the creek. As Tamila said, we are all volunteers, so there is no conflict of interest, and these are just the facts and output that we got while doing our research. So just wanted to say that very explicitly. And that's how this whole project started working. I met Tamila in February, and then we got this team together in another 1 or 2 months. And since then, we have been working to find out the state of pollutants in Conodoguinet Creek watershed and come up with some recommendations that we think can help us address those issues. So I think that is it from my side, and I will put my contact information in the chat if anybody wants to reach out after this session. I'll be happy to yeah, chat. I think that's it. Over to you, Marissa.
Thanks, Shashank. Um, so like he said, my name's Marissa. I'm a GIS specialist and I work at a clean energy company over in California, but I'm actually originally from a small town outside of Pittsburgh. And so that's kind of why I was interested in helping out with this project. Next slide. Thanks. So I'm going to show a series of maps that are based on the data that we found for the project. So we have these static maps that I'm going to walk you through today that show specific data sets that we found. But later on, I'm also going to show that we have a web map where you can go and you can explore all of these data sets in a more interactive manner. So first off, just a map of the Conodoguinet Creek watershed. So you can see running through the middle there, that's the Conodoguinet Creek stream line. And then it actually has an upper, a middle, and a lower watershed. And then inside of that, several different sub-watersheds. So the way that just generally data is organized is that there's a lot of different sub-watersheds and that they're all connected with each other, right? So I could zoom out and I could see the bigger like Susquehanna Basin watersheds that the Conodoguinet Creek is a part of and the water that's flowing within those watersheds and also the nutrients and the pollutants, they're flowing throughout the different water systems. Thank you. So this is a map of just the zip codes that are covered in the watershed. I know the text is a little bit small. Hopefully this makes a bit more sense in the web map, but this is just a way to help orient everyone. So if you know that you live in a specific zip code, you could come to the map and you could see, hey, like what's the extent of my zip code or what different pollutants or pollutant facilities are existing in my zip code. Next. Thank you. So this map is showing overall water quality as determined by the EPA and the Clean Water Act. So a little bit of context there is that there is an integrated water assessment that the EPA collects data for. In the case of Pennsylvania, hopefully no one or if anyone knows any differently, please correct me. But what I found is that the state of Pennsylvania has its own water quality standards that they use to do these assessments. And after they assess their watershed, they share that data with the EPA. So this data here is coming from the DEP, Pennsylvania's Department of Environmental Protection. And their last assessment, what they found is that 60% of the streams in this watershed were polluted. So that's over 624 miles of streams. You can see on the map there that like everything is red is something that's considered impaired for one reason or another. And also notable, and I'm not sure if this is a quirk of the EPA data or just something else that had happened, but none of these waterways were listed as having different types of protection plans in order to address that type of impairment, at least that I found. Next. So this map here is similar to the one that Tamala showed earlier, but it's showing overall land cover within the watershed. So the green areas here are trees, the yellow is going to be crops, the red is urban area, and then there's some smaller land covers interspersed throughout. But the big picture takeaway from this map is that agriculture and crops are really, really big in the watershed. So that's definitely a huge source of point source pollution that we want to look into. Also, there are really big urban areas where different pollutants could be coming from, like human sources, artificial playing surfaces, things like that. And it also has a bit of a regulatory component too, right? Because if you're regulating rural farmlands, that's going to look a little bit different when you're regulating like urban areas. So a lot of what we can see is that the red areas are around Carlisle, they're around Mechanicsburg. Yep, thank you. That's really where the population centers are. Next slide. Thank you. And so what we're seeing here in these four maps is based on those integrated water assessments. they evaluate the use of those streams for different types of purposes. So here we can see that in the top left, there's ecological use, and a lot of those streams were classified as not impaired. So ecological use is kind of like, like the wildlife and the habitat and those animals. You can also see in these maps that there's a lot of data that's missing. So this is just something that we found popping up again and again throughout our analysis. A lot of the times data fields just weren't filled out. And I do want to point out that there's a difference here between them just saying that there like isn't any data that they've done the analysis for versus they didn't fill the data out in the databases that we had access to. The latter one is really the problem that we ran into a lot. But also I'll go through the top right one is for recreational use. And the definitions that I found for recreational use is during the swimming season. So I think that's like sometime during the summer months in Pennsylvania. Is this water suitable for people to be going in and, getting their bodies in the water, basically? And one of the major reasons that we found those streams were found to be impaired was potentially because they had high levels of pathogens, maybe E. coli or other types of pathogens that were found in the streams. And if we go to the next slide, actually. Thank you. So these are the three big reasons that the streams were found to be impaired. So pathogens in the top left, that's really the major one. On the right side, you can see that there are also several streams where there's over sedimentation. So there's too much sediment flowing in the waterways and they're not healthy because of that. And then in the bottom, you can see that they were also testing for PCBs, so these plastic chemicals, right? But actually, the majority of the data set was not filled out, so we weren't able to take any types of useful analysis or assumptions from that. Next slide. We've had a lot of trouble with different data sets not being filled out. So the next few slides are just going to show you what we found for PFAS pollutions in the county, in the watershed. And so one data set that has been really useful is the EPA's unregulated contaminant monitoring rule. And over the past few years, they've had this rule about how to measure and test for PFAS chemicals. And the rule has evolved over time. So it's evolved both in the scope of chemicals that it tests for. As more PFAS become known, they're kind of like adding them to those rules and trying to test for them. Also, as more testing methods become available. But more importantly, I think the threshold levels for detection have changed and they've shifted as we've gotten more information about these contaminants. So our samples that were taken maybe earlier in the 2000s, so the third rule here, that was around 2014. The threshold levels for that might be lower or very different from when they were testing the chemicals again for UCMR5 or even what public health officials consider safe. So just be aware that there's like a lot of discussion around what is a safe level or what is the level for detection, and then how is that changing over time. And so here, sorry, go back. It's okay. So here, just to kind of like wrap all of that up, is that we have data from two different regulatory campaigns, 3 and 5, and that was in 2014 and 2023. And then what they found here is that these two facilities, the Shippensburg Borough Water Authority and the Carlisle Water Treatment Plant, were testing consecutively for these different types of chemicals. So along the bottom, there's a lot of different names there. They're all different types of PFAS or related chemicals. And you can see that all of these were found in the Carlisle Water Treatment Plant, and then a lot of them were consistently found in the Shippensburg Borough Water Authority. Next slide. We also sourced different types of academic research data sets. So there's one researcher from the U.S. Geological Survey, the USGS, who did a big sampling campaign across Pennsylvania from, I think, the 1970s until like the early 2000s. There's a lot of different data in there, but the one that we found that was the most relevant is that these PFAS chemicals were found near Hodgetown, I think it's Hodgetown, PA back in 2019. So it's notable again that you see these like popping up much further downstream, but also in the urban areas. Next slide. And then again, this is just some more of those data sets. Specifically, this one, they found a lot of halogenated compound detections. So it's another class of chemicals that we're looking at. And what you can see here is the map. So these are all the different sample points where things were taken. On the chart, you can see the different chemicals that were tested. So notably, this is a much shorter list and a different list than what was being tested in the other types of research. And then you can also see that they're testing like sediment, they're testing tissue, usually from fish, and then they're also taking water quality samples to try and figure out where the PFAS are popping up. Next slide. So now, just going to call out a few point source locations of the PFAS pollution that we found. I think Tamala mentioned these earlier, but this Navy Ships Parts Control Center and the Letterkenny Army Depot, both at different sides of the watershed, but both are classified as Superfund sites under the EPA, and that they are known to be emitting these types of chemicals, at least as they've registered with the EPA. Thank you. And next, there's these industrial businesses. And so the way that this works is any type of industrial facility that is emitting pollutants into the air, water, or soil, they're required to register with the EPA, and they're required to report on the types of chemicals they're emitting and also the amounts and things like that. And so this group that we see here, these aren't just the industrial businesses that are in the Conodoguinet Creek watershed, but they're also the businesses that are known to emit specific types of PFAS. And so we can see in the chart here the number of different facilities. So there's a lot of airports, there's a lot of waste management facilities. So that includes wastewater treatment plants. There's also printing, metal coating, defense, of course, electronics industry, petroleum, and then a few other types of industries. And so this is really useful if you're trying to figure out what are different industries that you want to like target for regulation or community outreach, or start looking for different types of alternatives for whatever they would using that are emitting these chemicals. Next. Okay. This is just some more of the data sets that we found, and I think this one is actually really interesting because this data set was taken by a lot of community members. And so what you're seeing here is along the Conodoguinet Creek from the left side to the right side, all of those numbers are different sampling locations. So I think it's like 1 to 35 different locations that they took along the creek. And they took their different water samples and then they sent them off for testing. And what you see on the bottom, that table there, those are the top 5 polluted areas. You can also see them on the map because they have larger circles. But this is a really great effort by the community members where they identified places to do testing. They went out and they got those testing done, and then were able to take that information and put it back on a map for community members. Next. And then speaking to that environmental justice component, these are some of the maps that I put together for the Conodoguinet Creek watershed in regards to environmental justice. And so the EPA has done this really great national effort of calculating environmental justice communities, which the state of Pennsylvania then followed, and they have their own environmental justice screening application. And so that's where this data comes from. It's coming from PADEP. And what they did is they looked at a lot of different things like people's age, they looked at the percent of poverty, and they also looked at the different types of pollutants in those communities. So sometimes that pollution could be things like air quality, like PM 2.5, if there's a lot of particulate matter in the air that you're breathing, but it could also be like the density of different types of pollutant facilities. And so what we see here is basically like a hotspot map of where different risks could be. So the one in the top left is just everything is put together, and we're just trying to see like who's experiencing the most pollution. So on the map, you can see that it's mostly like those really urban areas. But we can also break that data out into these other maps to understand the risk and the toxicity a little bit more. So for example, if we were really concerned about chemicals that affect either the really young or the really old, we could look at those two maps on the corners, right? The percent of population elderly and under 5. Or if we wanted to um, do community awareness around specific types of solutions like the water filter that Tamala put into her house that may have some type of cost inhibiting people from being able to afford that. We could look at maps like the population of percent poverty and then be able to target those solutions towards communities that might be more economically disadvantaged. Next slide. Yeah, so that's just a sample of all the different data and the maps that we found. This is a bit of a summary slide of all of that. So altogether, we had a lot of different chemical sampling data sets, water quality data sets, facility data sets on the different industries, and then other data sets that we found. But we also faced a lot of these challenges that we have here on the right, where the years between the sampling could be really vast, right? Some of those samples were taken in the 1970s. Some of the sampling is really infrequent. We might have one point at one place in the watershed, and then it was never visited again. A lot of the data was just empty or missing. It was really hard to figure out what was going on there. The chemicals are changing. It seems like a lot of different departments and agencies and people are testing for different things. And then generally just like sewing all the data together and making it make sense were some of the challenges that we faced. Yeah, that's all for me.
So this is these slides here are just some slides from American Water that they did for PFAS testing to try and see if they can find a point source for the PFAS all along the creek there. You could see their points of testing and similar levels of PFAS testing. You can go to the next slide. And this is just another one of their slides that show the different types of PFAS in the areas in the last slide. And they came across basically that legacy furniture store or manufacturer that was contaminating the groundwater and that was going through that pipe into the creek. So that's it. All right, so Kiara, she is our scientist who is going to be breaking down kind of like the method for how we're going to be trying to attempt to make our recommendation for what source location and chemicals we should focus on for our testing. Kiara, go ahead.
Hi, everyone. Sorry, I have a bit of a cold, but I'm Kiara. Shashank mentioned earlier. I'm a grad student at Princeton, and I work on biological degradation of PFAS. So we use bacteria to help degrade these contaminants. First, I'll be sharing a little bit about the different contaminants that Marissa has highlighted, and then I'll talk about our sort of methodology that we're interested in using. Okay. Sorry. We've talked a lot about PFAS, but I'm not sure that everyone's familiar. For anyone who isn't, it stands for per and polyfluoroalkyl substances. These are essentially highly fluorinated compounds, and they're useful in a really wide range of applications. There are over 200 unique applications, ranging from things like household products, consumer products such as cosmetics or nonstick cookware. And the bigger range or larger scale applications include things like aqueous film forming foams. There are currently regulations for some of these compounds in drinking water, but only 6 of them out of roughly 1,500. And the number of compounds can range pretty widely depending on how you define PFAS. While there's regulation in drinking water, there isn't regulation for things like biosolids or soils that might be contaminated. They're linked with a host of different health adverse effects, including things like damage to immune systems, damage to liver, decreased fertility in women, and low infant birth weights. So there are a lot of concerns about the toxicity of these compounds, and that's why they've started to regulate them in drinking water. In terms of testing, it's pretty expensive to analyze and detect these compounds. They require something like liquid chromatography, which will separate a sample and then analyze each individual compound based on their specific fingerprint in this instrument. I mentioned the testing because if we want to see and understand if we want to make recommendations for testing, we should understand what testing would involve. So for PFAS, it's pretty expensive and requires specialized training. I will mention also for PFAS, because of the drinking water regulations that came out, drinking water facilities will soon be required to report their PFAS concentrations. But since the regulation came out, they give everyone a little bit of buffer time to figure out how to test and how to regulate and degrade these contaminants. The second compound group that I'd like to talk about is another halogenated compound. Marissa mentioned these PCBs, polychlorinated biphenyls. The biggest concern for these are that they bioaccumulate and biomagnify in aquatic life. And then our primary exposure to them is through consumption of aquatic creatures such as fish. So these are also associated with a host of different health consequences, particularly endocrine disruption. And their applications include things like electricity production, incineration. They're in pesticide formulas and are used in hydraulic fluids. And as Tamla mentioned, they're also associated with plastics. Again, for these compounds, testing is pretty involved and expensive. Again, we use gas chromatography, very similar to the liquid chromatography, but these are more volatile. So we'll look at them in the gas phase. Next, Marissa mentioned these polycyclic aromatic hydrocarbons, the PAHs. That was that map that had the red circles on it. These compounds are primarily from a lack of complete combustion. There are some, I think, natural emission sources like volcanoes, but a majority of them are anthropogenic from humans in things like, as I mentioned, incomplete combustion primarily. So we get exposed to these volatile compounds through the air. And testing for these, since they're volatile compounds, involves gas chromatography again, or high performance liquid chromatography. And all of these testing methods are, again, expensive and require specialized training. Tamla maybe had mentioned this a bit earlier. There's this toxic release inventory that indicates that requires places to report what they're outputting in terms of toxic chemicals. And if we looked at Carlisle, if we put in the zip code 17013 for Carlisle and put a 20-mile radius on it, then we see that there's toxic release. Here's the legend across these areas within the proximity of Carlisle. And these are the distribution of contaminants. We have a lot of heavy metals like zinc and nickel and aluminum. But then we also have these other compounds called diisocyanates. On the right here, this is the contribution to the human health harm risk. So even though we have a wide distribution here and maybe not a whole lot of the diisocyanates, you see that the diisocyanates are contributing a lot to the human health harm risk. So diisocyanates are compounds that have the cyanate group on it, this N-double-bond-C, double-bond-O. These are associated with asthma, dermatitis, skin irritation, and they're used in things like coatings, adhesives, sealants, and most commonly in thermoplastic polyurethane production, and this can be used in sports equipment. So for all these compounds, you're really facing them in our everyday consumer products. Same with the other ones. The testing involves expensive equipment such as gas chromatography or the high performance liquid chromatography. And this also requires some sample preparation. If all this testing is pretty expensive and requires specialized training, then the next question is how do we test for these compounds in our waterways? One sort of proxy test that could help screen for overall stream health is called macroinvertebrate testing. I've actually conducted this kind of testing here, and it's kind of fun to go out into the stream, but you take a D net and you sample in the water, you kind of pick up some of the rocks and boulders that are there and scrape off the macroinvertebrates. And the ones that are more tolerant to pollution will be present in polluted areas, and the ones that aren't as tolerant will not be present. So we can use macroinvertebrate testing to look at the diversity of these small organisms. And that diversity gives us a general sense of the health of a stream. And people have used macroinvertebrate testing for PFAS to screen for areas that might be polluted by PFAS, for PCBs, and for PAHs. So I also want to mention this type of testing is relatively inexpensive compared to the others. So if we wanted to do maybe first an initial screening with macroinvertebrate testing, we could do that to see which areas we want to do further testing on. And then we save costs by not sending everything for this expensive analysis. In our whole project, we wanted to look at these different point sources. Marissa mentioned these a bit on her maps. We have airports, agriculture, pollution from development and disposal and infrastructure, as well as manufacturing. Big key point source could be military bases and pollutants coming from these petrochemical facilities. And lastly, the Superfund sites. If we were to have more data, we would want to put it into a more comprehensive model. With the data that we do have, we were able to do the spatial analysis that we showed earlier. But the ultimate goal is to put this into a bigger model that considers both pollution burden and population characteristics. Some of those population characteristics Marissa showed earlier, things like the vulnerable communities that are elderly or children or in poverty. So this pen and virus screen method is a way of assessing the pollution burden for different communities, and this was done across the state of Pennsylvania. They identify environmental justice areas, and they did this for the purposes of working towards permit applications. They have 4 different components and 2 categories within this method. There's pollution burden and population characteristics. Pollution burden includes environmental exposures. And for us, this is our pollution data. And environmental effects is a proximity-based risks. For us, that's the proximity to some of our potential point sources. Population characteristics will look at sensitive populations that have maybe increased vulnerability to some of these environmental threats. And for us, we would also incorporate the toxicity of our pollutants. Socioeconomic populations would essentially use the EJ model some of the EJ scores that they have already put together. So you calculate a value for each of these indicators and you kind of put a percentile to each of these block groups relative to the statewide distribution for each of these. So just in a, I guess, more detailed schematic, we get a percentile for each of our indicators, and our indicators could be things like PCB concentrations, and we look at a percentile for each census block over the whole area, in this case, our watershed. And then we get component scores and put them into a final score. For their EJ model, they were looking more so at ozone, particulate matter, and pesticides. For us, we're interested in extending this further to look at heavy metals, these persistent organic pollutants, such as the PFAS and the pesticides and the PAHs. And that's for the environmental exposures portion. For the environmental effects, we would include the different point sources that we indicated earlier. So the biggest concern for us is that we need more of this pollution data, for the environmental exposure portion. We have census data and we have the existing EJ scores that are out there, but we're really, I guess, reaching out to everyone to get more of this pollution data if possible. This is an example of what their final EJ model looked like. These are the blocks, and the darker colors correspond with places that are of more concern that have been identified as environmental justice areas that are perhaps filled with more vulnerable populations. This is Carlisle relative to the rest of Pennsylvania. So
So
on to
before-
strategies. Yep.
I thought we could take a break, Kiara, and see if there's any questions or comments that anybody has.
There was one in the chat, but not sure if Julie's still.
Yes, there was a question. Let me find it. They were asking about how is an HDP pipe compared to a PCV pipe?
We see.
Oh, the high density pipe. It's better, but it still carries a subset of toxic and microplastic releases, depending on how it's used, and the temperature, pressure, different attributes that the pipe is exposed to can impact the leaching and the microplastics that get into out from that pipe.
So if there's not any questions and you want to continue, we can also discuss them at the end or when we present the
Sure.
next one.
Yep, sure, go ahead.
Okay, next we have the strategies and solutions. And Marissa, let me know if you want to share your screen or if you just want to go through the slides.
You can go through the slides.
Yeah, so two things that we've made. One is the map, and the other one is the survey form. So in this pollution report form, you can upload different information related to different points of environmental concern. So let's say you see like a pipeline leaking somewhere, you can take a picture of it here and fill out some information. You can also write more information about what you're observing. You can do like a little voice recording or something like that. And then this form that you fill out, it goes to our team and we review it. So Tamala reviews it. She'll review like what information is there, also like who submitted the information. And then once we take out any personally identifiable information, so like your name, if you did do like a voice recording or something like that, we wouldn't post that. We might like just type up a summary of what it was, but we would take that report and then publish it on our map. So on the map, you can see well, not here, but like on the map, there's a data layer called firsthand reports. Yeah, perfect. Thank you. You can see it in the top right over there. There's this data layer called firsthand reports, and those are the different things that either community members have submitted or, Tamala or someone else. This is data that just stays with us as a team too. It's not being shared out to anybody or any third party or anything like that. And then actually, can I share my screen to show the map? Yeah. Okay, let me pull it up. This over here. Okay, I'm gonna do this. Okay, so this is the web map that we've created. I'll put the link for this in the chat afterwards. But just real fast, the way that you can interact with this map, you can type your address over here if you want to quickly navigate to it. On the right-hand side over here, these are all the important buttons. So specifically this third one down that has a bunch of little, like, you can look at them like pieces of paper layered on top, but this is all the data layers that we have. Move this Zoom screen around. So by toggling them on and off with this little eye icon, you can see different information. So for example, let me start by turning all of them off except for the Conodoguinet Creek. From that, I can come down here and I could turn on the hydrology boundaries to see where the boundaries of the watersheds and the water basins are. I can also come up here if I expand chemical sources. This is a lot of that like toxic release inventory and other data sets that we saw. So if I turn on industry, these are all the different industries we know are emitting PFAS. And I can click on any of these points for more information, right? So if I click on this point here, it tells me what type of industry it is, the name of it, and then it links to more information about the report. So one thing you could come and do for this map is if you came and you, oh, this one. So you came and you turned on zip codes. So let's say you want to see everything happening in your zip code. Let's see, which one's this? 17013. Let's say we're looking at that. We can zoom in and we can click on all of these different points to see like, oh, there's, the Hoffman Electronics shop is emitting some PFAS. There's the the Army barracks that's in there too. What's over here? There's a metal coating plant. And so this is a good way to get more aware of like what's happening around you and also specifically see the different PFAS information. And then one last thing I'll point out is if I come here and I turn on land cover and then turn on the contaminated waterways. Actually, it's a little, I don't know. So if I turn these two on and off, I think one of the interesting things that you can see, like overlaying this data on the map, is that how much these impaired waterways overlap with the agricultural areas, right? It's almost right at the boundary of them that the streams are starting to become impaired. And I think that should also speak to the different types of solutions that we're looking for, right? Like we're seeing different things happening in different parts of the watershed. And so whenever we're trying to do some type of like testing or other types of policy and solutions to address it, I think it's really important to look at the map to see where it's happening and making sure that the policy and solutions also target things spatially. Yeah, so I'll take the link for this. I'll put it in the chat. This is open for everyone. Please go through and click around and share it. And then I'll also put my contact information. If anybody has any questions about the map, feel free to shoot me an email. Oh, I think Tamala's already put them all in the chat. Thank you, Tamala.
Yes, we had a questions about how should citizens reach out to develop water testing. And I think Kiara answered a little bit of that, saying that they can go to Alarm, which is a citizen-sized organization, and there's a few other places. But if anybody has another input, it's welcome. And we also had a comment saying that that's a great map, and if there's other maps similar to it. I think there's the EJ screen model by the EPA and the DEP from Pennsylvania also has maps. But I agree, this map has some unique, some things of its own. It's a bit different too.
Yeah.
Okay. Well, let me introduce myself. I'm Astrid Lozano Costa. I'm a science educator, and I'm interested in inquiry-based learning and STEM education. And I'm the communication and outreach specialist for this project. If you can move on the slide, please. Yes, so part of the work that we're trying to achieve with community outreach is education, community participation, and just to listen to the stories and voices from the community. And we're trying to do this through different, in different ways, through interviews and surveys, hopefully some citizen science, multimedia materials, and tags such as this one. Next slide, please. And some of the, I guess, the initial work that we've done is just gone through a series of stories, newspaper stories about Cumberland County and the region. It kind of just asking about what are the environmental issues and the views of people or attitudes around those issues in Cumberland County. And some stories that have come up is throughout this this search. It's one of climate change, extreme events, and flooding, right? So with the changes brought about by climate change, we've seen a lot more stories about the increased frequency and volume of rainfall, which raise the water levels and can sometimes mobilize the pollution that was from one place to another. This could be through the runoff or flooding, right? And one specific instance that affected Cumberland County is, I think it was in October of 2023, an oil spill around the Conodoguinet Creek. And a few months later, there was heavy rain, which could have this oil, and we had some water restrictions to do because of that. Next slide, please. And one of the things that also came up through reading these stories is that some solutions that are actually being implemented around the community, this one is in Harrisburg, I believe, are rain gardens. So some neighborhood associations have started to develop these rain gardens which have worked, to help accumulate the water and divert it from the streets. This is an example of what's called green infrastructure, and people are saying that they're helping tremendously. If you read one of the quotes there, it says that you don't see the area flooding like it used to. So this is one of the things that we wanted to do through outreach, is listen to the voices of the community, what the issues are, and and we even come across some of the solutions that communities are implementing. And another thing that was gathered from this news is that, for example, these rain gardens, they have unintended consequences like gentrification. And they could, through this project, we also think that it could be an opportunity for remediation. If we have these rain gardens here, they could also help with flooding, but maybe we could also put some plants in there that help collect some of this pollution carried by the runoff in these places. And the gentrification story, it's just one of the many things that we need to be aware of when we trying to implement solutions. We also need to be aware of how these solutions could impact society and our communities. Next slide, please. So this was just an initial work just to see, what's out there, what are some of the stories and concerns of the community and some of their voices. Another thing that we're doing as part of our outreach for these projects is cricket snapshots. And this is just a photo voice project, and it's designed to be just a space where the community can share their pictures and sounds about nature or pollution. and just post different events related to the environment, just so that we can have a space for the community to, to participate and I guess just to just to express themselves, I guess. And next slide, please. And some of the work that we are also trying to, this is a future event that we're planning, is just reaching out to community members, especially the ones that spend time around the creek, around nature, and this is a project that this particular event hopes to implement a lot of the topics that we were talking about, right? Like community education and participation. We're planning to have like a program for creek defenders. It's it's geared towards anglers and paddlers and whomever spends time on Conodoguinet Creek. We're planning to have them assess stream health through the fish protocol, which by Penn State Extension, which is just looking at kind of like the water conditions, the vegetation cover, and assess, wildlife, and just assess how the stream is. We also plan to teach them about the pollution report form, so the community themselves can be empowered and, participate in letting us know where there are any issues around their community. And we're also planning to collect information through an environmental health survey. Next slide, please. So this is just some of the efforts we're trying to get in touch with the community, hear their voices, and also promote community engagement. We are also going to teach them about the health advisories that are around Conodoguinet Creek for different, these are like this is our advices of how many fish meals per month can people have on a particular stream, given some of the pollutant concentrations that the DEP has found on fish tissue. Next slide, please. And we also want to teach them a little bit about some of the emergent contaminants like PFAS. And as you can see, they're found in a lot of places, including drinking water and fish. Next slide, please. And another project that we're trying to develop is kind of a natural history interviews, where we're trying to reach out to schools and libraries and see if we can develop just a team that can go out in the community and just ask different natural history questions and stories that they have about the creek, about the wildlife there. And this is just another way to engage the community and hear the community's voices, what their concerns are. And yeah, that's some. I just wanted to show you some of the work that we're doing with outreach and just to get education and community engagement out there. So let me know if you have any questions, but that's it.
Thanks, Astrid.
Yeah, thanks, Astrid. That's great. Does anybody have any questions or comments or ideas?
Somebody was asking here if there's a correlation between the water levels on the creek and pollutant concentrations, and that's actually something that I collected some data to kind of figure that out, but I am not aware that there has been any academic study on that, or there's any, but there have been. It is known that runoff does carry out a lot of pollutants into streams, but I don't know if anything.
Yeah, there's actually through Carlisle's PFAS data, when the water levels are lower, their PFAS are more concentrated. When the water levels are higher, it's more diluted. So yes, when you have higher rain influx, you are diluting the PFAS concentration. So like 1 part per trillion is a drop in, 10 or 20,000 Olympic-sized swimming pools, right? So non-detect level is 4 parts per trillion, and that's what the current EPA maximum contamination levels are for PFAS. So that kind of like lets you know about how small amount of that particular chemical, and then some others are similar, you need in the water. But yeah, when you have less water, less dilution occurs.
I think that will be a different relationship for different pollutants because the runoff can pick up, something like heavy metals or something that was around in the soil and bring it to the creek. So yes,
Yes.
that so it could be
That's-
different relationships. Yeah.
Yeah, yeah. Anybody else have other questions?
Are you gonna do this mentimeter again, or?
Yes, the
Or is it
Mentimeter,
Q&A
yes,
time?
yes, we'll do that. So yeah, we can do, let's see, we're gonna do the draft recommendations first. So Kiara and Shashank will be doing that.
Yep, so just to reiterate some of the points that we made earlier and some of the contaminants that we highlighted. So far, we've seen a lot of these polychlorinated biphenyls, these diisocyanates, PFAS we've talked about a lot, microplastics and pesticides, heavy metals, and these polycyclic aromatic hydrocarbons. So these are kind of the main focus of our recommendations in terms of the compounds that we should be looking at. But I also want to emphasize something Marissa also said earlier. Locations that we don't have pollutant data for are not necessarily pollutant free. It's just that we don't have the data. So this really kind of alludes to our need to have more data spatially and temporally. And that's where I think everyone can play a role in participating and helping us obtain some of this data. So we want to make recommendations for testing locations. And so for what we've seen so far, these two areas of concern include Carlisle. We have the Army War College that could be a source of PFAS, the wastewater treatment plants that could be a source of PFAS in the water and also in the biosolids, along with a lot of other contaminants that are just concentrated when we have the wastewater treatment plants receiving water from all over. The wastewater treatment plants would also have heavy metals, PAHs, and microplastics. I think Tamla mentioned Carlisle Syntech earlier and a lot of other tech manufacturers. They're associated with potential PFAS contamination, heavy metals, PAHs, and microplastics. The other place that we want to hone in on for sampling and monitoring would be Mechanicsburg. If you remember back when Marissa showed the map, these two areas have a lot of the built area for the land cover use. That was the red color. And that also, we found land cover use also very much overlaps with the impaired stream area. That could be a result of sampling bias, but it's important to know that where we have a lot of the built-in area, that's where we have a lot of the stream impairment. So Mechanicsburg, the naval base is a major potential point source for PFAS, and the Kreisen facility that Tamla mentioned has PVCs and also microplastics. The other potential point sources we want to point out include the North Middleton Legacy Landfill, the Mill Creek Legacy Furniture Facility, and agriculture, which is spread out across Carlisle. It would be important to test around those areas to see how pesticide pollution, PFAS, heavy metals, pH, and microplastics might be present there. So one, I guess, call to action and potential project as a follow-up for the project that we're doing now is to initiate a water sampling day. The Pittsburgh Water Collaboratory put on a water sampling day that I think has kind of inspired us. If we could do something similar, I think it would be very impactful to get more spatial data across the watershed. For them, they had a water sampling day. They went out and I think sampled around 40 different locations across this watershed. This was a volunteer event. So people would come, they would take pictures of where they were sampling and they would take a water sample and then later submit it to the group and that would be sent out for testing. They were looking at things, basic water quality parameters like nitrates, phosphorus, nitrogen, iron, chloride, and sodium. And then they put this all together in a story map that it's interactive. You can scroll through it to see where they sampled, and you can see which points have which concentrations of these essential water quality parameters. But for us, it could be interesting also to include the macroinvertebrate testing. It's pretty easy for volunteers when they go out. As I mentioned, they use a DNet, they sample the macroinvertebrates, you put it in a jar, and then you send that jar for testing. And that testing is relatively inexpensive compared to some of these more specialized techniques like the gas chromatography or liquid chromatography. So for this type of sampling day, I think it'd be really good to collaborate with other entities out there, maybe Alarm. And I know someone in the chat asked about how we can initiate this kind of testing. So I think this is kind of open to collaboration and discussion, further discussion to develop a sampling day. And then back to Tamla for the multimeter.
Okay, great. So, Astrid, if you want to put back in the thing for the Mentimeter in case people closed it, and your next question is up. And the question is to take action to address chemical and microplastic pollution. So it's asking, you know, do you strongly disagree to strongly agree for yourself to take action, for your organization and business, for your community should take action? Should your governing leaders take action? Should NGOs take action? So you can complete that question. And I'm going to put
do you want to try to share your screen so people can see the visualization of the Mentimeter?
yeah, I was gonna do that. So far,
I'm gonna try to do this.
let's see if that'll work here.
Does it work? Oh, can you put that code back? Oh, you're moving on. I know how to find you.
Okay. So far it's looking like people are thinking that the governing leaders, the regulatory bodies should be working on this. We've got about a 4 for businesses, organizations, and community, and for NGOs, and a 3 for individuals. All right, let's go to the next question. And I think it's our final question. Oh, why is it the repeat question? Okay, this one is what actions should we take to address pollutants in our watershed? So you could be responding as an individual, as an organization, as a business, or as a regulatory agency. Your responses can be through whatever you put. And if you want to maybe put on there, like if you make a recommendation, say to put a rain garden, are you speaking as an individual? Are you speaking as an organization? Or so increased testing, who should be doing that increased testing?
Pamela?
Yes.
I go on record. I wasn't able to get that code, but
yes.
Something that really stood out to me, because Wade and I, as you know, but not everybody know, we've lived in multiple counties within Pennsylvania. We lived in multiple states and gotten involved in environmental issues. And yeah, I continue to be concerned about, the potential duplication that's out there. I mean, I think, we're trying to fight polluters. We're trying to, maybe fight's not the right word, as far as trying to get governmental organizations, more active or, more up to date. But I was really hit by the macroinvertebrate testing, because I would hate to see, your group go out and duplicate, testing that's already being done by CCWA, it's already being done by Alarm, it's already being done by, DEP. That seems like, and especially if it's a lot less expensive than, a lot of the other testing. Yeah, that almost seems like a no-brainer to me. And it sounds like it can test for a number of contaminants. So I don't know, that's just something that really
Yeah. So to that point, when I first started this, I was looking to macroinvertebrate studies from the beginning because they test the long-term health of the stream, right? Versus if we go and test with, a water sample or a soil sample, that's very transient.
It's just
right. It's a moment, and you can miss it. And you could tell that from the sampling that's been done, like by PA American Water and our other municipalities, right? So I definitely think that using macroinvertebrates and or, fish studies, a person named Olivia, a grad student for Penn State, I think, my memory serves, she was doing PFAS in the Susquehanna and the flathead catfish, which is an invasive species. So we can learn a lot. Like she noted that there were concentrations so much higher in certain places than others. So I think using the macros in our fish that are in the environment is going to be really helpful to, maybe, instead of, having the expense for long-term purposes, for sure.
It's not duplicating what's already being done. But at the same time, clearly what's being done by, the testing that's being done now needs to be upgraded.
Right.
To include some really scary stuff.
Yeah. Right now, though, Alarm has had it on their agenda to include macros for the volunteers. I'm a Alarm tester volunteer, as is Susan and you, Karen.
We're going to become
you're going to become. Oh, you are too, Elizabeth. Go. Yes. So that's been on the agenda, right? But it hasn't happened. So maybe this is the the Creek Defenders project can help push that initiative forward. And because they've moved to their model where the community helps decide what they do and test. And so, this is something that we hope to bring up to them. I had talked to Julie when she, back when I started this project, but because she was in transition, they weren't able to put it on their plate to think about it, but perhaps they are now. Yes, Elizabeth.
So, Tamara, can I just ask, just to follow up to the macros question? I think my understanding, comment first from Alarm, was that I think they were looking at identification down to the family level, and that there were some challenges with training volunteers to kind of have that precision. So I think in your model, you're suggesting having those brought to labs that can then do that very specific genus level identification, or are you suggesting that volunteers?
Well, we would have to talk about that, right? Okay. These are the discussions that need to happen.
Gotcha.
Exactly.
And then are you also suggesting then that maybe once baseline kind of macro invertebrate data is understood for specific areas, it could indicate areas where you might want to come back and do chemical sampling based on what you're finding with the macros?
Yeah. Yes. Okay. Yep. That's exactly right. Yeah. So if you want to put back up the PowerPoint, we'll finish us off here and then finish off our solutions, because the solutions are very critical, and how you guys could integrate in the solutions are critical. How is that not stop sharing? Okay, try it now. Okay, great. All right. So, so we kind of already went over this slide, so I'm not going to do it again, but this slide is telling us why other people outside of the regulatory agency needs to step up and look into this. After speaking with them, they are relying on us. We're the boots on the ground. It was a regular person, myself or a neighbor, who contacted me who found that impaired stream for the legacy landfill in North Middleton. It was a regular person who found the oil leaking into the Conodoguinet Creek, right? It's not always the regulatory agency or even other organizations. That's why it's critical that individuals are a part of the solution. So we really need data heavy, right, to do a good job on being able to protect us. And we need you guys to help us to figure out what locations and what pollutants we're going to be pinning for using our time and our resources. The team is just here to help get you information, but it's ultimately gonna, and make our recommendations, but it's ultimately up to the community to decide. It's not up to us. And then what, when we figure and thinking about the point, non-point sources and the chemicals, we need to be thinking about why are these locations and pollutants important to monitor. Going back to some of the things Marissa was talking about, what will the benefits be for addressing those? What are our outputs and our outcomes? Simple, educational outreach is critical, including to our doctors. I go to the eye doctor, my regular doctor, my GYN doctor. They are not aware of the chemical toxicities in plastic, and especially, for the most vulnerable population. In fact, my OBGYN, she was so dismissive, shut it down hard. She was like, no. And I was just like, whoa, this should be a pamphlet should regularly be given to a mother who's planning to get pregnant or pregnant of how to avoid these toxins, because there are ways of doing that. Policy is particularly important. So for policy, we can regulate chemicals as a class. We can identify, these artificial playing surfaces and put bans and ordinances. We can help support regulation for single-use plastic ordinances and laws. The San Francisco has a precautionary principle ordinance, which I love because that's what we should be doing. We can help our regulators pass laws on PFAS-free packaging, personal care products, textiles, and building materials. I mean, it's in mascara, toilet paper, periods. It's on, it's in everything. We also need to test our biosolid before its application, support organic agriculture in a big way. With the biosolids, it's interesting that 97% of microplastic particles and fibers get removed from the influent to the effluent. However, there's so much in there that it's still a heavy burden on the environment and carrying the chemical and microplastic toxicities still, even after that. But if you think about that, what does that say? Where is those microplastics going? Yes, we've taken them out of the stream for the downstream, right? For the next township. Theoretically, they should have less, right? Microplastics, but then they're ending up in our biosolids, the chemicals and the microplastics. So then what do you do with that? So that's why I think, testing is so important. And there are arguably ways to get rid of the heavy metals and PFAS and some of these other chemicals and stuff from biosolids. But it's definitely something we should, address in food processed residuals, because now we have Maryland and Virginia shipping us their food processed residuals, which besides a barrier that they're supposed to stay away from a creek, there are no regulations. We don't know what it is, when it's coming, how much is coming. It's like major Wild West out there.
Virginia is shipping up here?
Yeah, and Maryland, yeah.
Maryland, I could
because they put in very strong regulations for the food processing residuals, and then for education we could do well testing, because you saw on the AJ map was out in the agriculture field. So think about all those people with wells. They have no clue about the contamination for the regular water, things that Penn State Extension is trying to help with, right? No less these other emergent contaminants. And so these are some things we can do. And like Astrid says, we want to tell stories, and we need to bring all these components together, all these different sectors aware in order to help improve the health of the community. It's not something we can work on alone. Oh, I'm sorry, you should be on the next slide. There you go. So, and you guys can really help with this. All these organizations and everything. I noticed now Penn State Extension is having a webinar on artificial playing surfaces. So yay, fantastic, that's great. And then some things that we can do in community science is, I know some of our townships or municipalities are a part of Birdtown, PA. I just talked tomorrow. We want to try and expand that program. And I'd like to match the organizations and Boy Scouts and 4-H and different people who can help implement these best management practices to help a community, all of them get gold. Tree keeper program, we can do litter audits. People can contribute to Creek Snapshot. So if you guys are doing, your programs that can help your watershed, post it, that's happening on the Creek Snapshot, and participate in the pollution report form. Look at the map. So these are all things we can do. And then next slide. And this is what we're protecting. We need to apply the precautionary principle. Back in the tree keeper, I forgot to talk about that. There's a bunch of funding that Carlisle and Cumberland County are doing for a program, and I was like majorly applauding that and want to get us all involved in helping with that through the tree keepers. That there's a session coming up for training for that. It's what, 2 weeks long? So and last slide. And I just want to thank you all for coming, being here today, hearing everything. And there are very much more specific details of how you can help, but this is just kind of an overarching conceptual things to just kind of put in everyone's forefront of their brains. So yeah, you can reach out to any of the team to share data, to ask questions, to help with educational outreach, to help with testing. We need all of that. Today I'm meeting with the Anthropocene Alliance at 3. If anyone wants to join me in a meeting for that, I want to try and get the community grant fund to get funding for the project for testing and outreach. And so that's at 3. If anyone wants to join in that to help for that grant project, you're welcome. And that's it. So in the last minute, if anyone has any further questions or comments, we welcome it. You guys were a quiet bunch.
We're in shock.
You're in shock. Yes. Yes, Wade.
Are there any other countries around the world that can serve as models?
Oh, very much so. The EU,
The EU and New
yeah.
Zealand and Australia.
Yeah. I work with them a lot. And,
Oh, you do?
Yeah.
Okay.
Yeah, and I've talked to them and what they're doing in their watershed and with their community outreach and everything. But they have stricter regulations.
They do.
Yeah, a lot. So just for cosmetics alone, I don't want to throw around statistics because there's too many.
So the public over there is.
But it's literally they will have I think it was 1,200 chemicals for cosmetics regulated, and we have 60.
Their food supply is better protected.
Yeah, but they still have, and in spite of this, I just read an article this morning, they are having issues with pollutants in their watersheds. I just read the article this morning.
Sure.
Well, you can't have that kind of dense population without that. Yeah, I mean, you could, but that's kind of pie in the sky.
Do we have any questions in the chat? Astrid, have you been noticing?
No, there's not many questions, but we encourage you to share any ideas that you have about how would you use the Creek Defenders map, how we could incorporate or implement the city pollution report form for use in the community and for data sharing. But yes, I think we answered most of the all the questions that were asked.
Daryl, Aaron, Jen, any questions? Barbara, I thought you had one, I remember. You can come off mute if you have a question. Susan, anything?
No, I need to go.
Okay, see you, Susan. Thanks for coming.
So I have lots of questions, but I think the first thing I should do is get in touch with the closest watershed foundations near me and see what they've done, because I know they're testing their creek. That's the mountain. I'm sorry, I can't remember exactly, but it flows into Laurel Creek, and it's in Fayette County in Pennsylvania. And they've restored a large percentage of that from mine drainage, but I don't know if the tributaries from my section of the woods have been tested for macroinvertebrate wellness, So I should do that. And there's just so many things we need to do. Anyway,
you're working on a lot of things, Barbara, but just get in touch, but see how you can connect your work with the petrochemical work that you're doing with your creek, because they're intertwined. And we don't have fracking in our region, right? And so we think that we're free from the petrochemical grip, but that's not true, because the Mariners East Pipeline had a leak in Latort Creek, and I think it was over 3 different leaks happened there, and that's just a creek that runs right through Carlisle. And then these oil drum spills that are occurring, and you saw the one. I
should go to the downstream, the Mountain Watershed Association, and ask them if they have done any testing that would catch that, because we have pipelines around here, we have compressors. And we know that there's going to be push for more injection wells in the future. So, we'd like to see legislation that limits that, but it hasn't been a focus for a couple of years. So there's a lot to be done. But I know they've done something work, and I don't know exactly what their results were. So the other issue is you advocate for reverse osmosis filters. So we should ask how many people actually have them, and would they be interested in getting them? And are there any programs that would support the cost? You know, that's something that we should try to get developed, because I think that's going to be more necessary in the future. There's no programs like that now, are there? That would help?
No, I think one of the biggest things we can do is, before filtering, is get testing for private well owners is the biggest thing I think we need to do first, and funding. And so maybe the grant funding that we're getting, hope it could be for that.
So many people have private wells, but the recommended industry to test the water doesn't automatically test for PFAS. You know, you have to ask that. I think you sent me to a special laboratory for that in the past, and I probably should repeat that test in intervals.
Yeah. There's, I think it's, if memory serves, Cyclopure has a test for PFAS for $79, I believe. And so that's reasonable. Now, I think I looked at it. Oh, it's been too long. I think it's actually DEP and EPA approved. I'm pretty sure, because I was going $79. Surely that's not going to be, EPA certified. I have to go back and look. But even if it's not, and it does test, gives you results that are sort of high, then you could push to maybe find or get, somebody to come out and test, based on that result. The other thing that's important to understand is that impaired waterways are primarily for what I call VMPs, so silt, sediment, nitrogen, and phosphate. They're not, some heavy metals are in there, but for the most part, those impaired waterways have nothing to do with chemical and microplastic toxicities. And so that's very important for people to understand. So we need to start bringing those to the game. They're in the game, they're playing, but we're ignoring that we're getting slaughtered by them, right? So, they're not going anywhere quick. So we need to acknowledge that they're playing a game with us.
I have another question I have asked before. Is there any documentation of the effect of internal combustion engines, roads, on the water? If the road goes right past a creek and, it's heavily traveled by ATVs or Jeeps.
Yes, there is, and there's some. We have I have an Excel spreadsheet of I don't know, what did we get up to, like over 250 data sources right now. But yes, there is some data on that kind of thing, Barbara, and it's definitely heavily impactful.
Yeah. Well, I might ask you to share that with me sometime soon.
Okay, sure.
Thank you. I think this was a fabulous Zoom, and I'm so glad that I listened to it and that you're doing this work. It's really great. And I admire your energy and persistence.
Oh, thanks, Barbara. Well, I appreciate everything that you're doing and your work and your writing and everything. And so,
well, keep
you're
going.
my hero. Anybody else? Any thoughts? Well, I hope we've inspired you to take action and to know that there are things that we can do and we should do, and that, the tools are out there. I have a whole bunch of community tools for addressing pollutants and toxins that I've just come across in the last week to a month. And EPA just put out a document, and yesterday, in fact, another document where they have training for engaging the communities. So I have it all, just going through it and just using it and doing it. And it's going to take the entire community to get this done and be involved. But you know, we can do it together, guys. It's pretty exciting, I think. So I appreciate you all. All right, team, thank you so much. Go and get rest and continue all the work that you haven't been able to do because you've been preparing for today. And the rest of you audience from in the room and online, I appreciate you and thank you so much.
Well, the two in the middle are from Texas. She's from Princeton. She's at Princeton.
Mhm.
She's in California.
All right, team, thank you. You
Bye.
can text me, call me, we can meet individually, and if you want to come to the 3 o'clock for the grant and want to throw in ideas, you're welcome. Thanks.
Okay.
Bye.